Hi, in this video I'm going to walk you through the process of emulating Raspberry Pi's ARM64-bit image using QEMU. I have a fresh Ubuntu 20.04 installation here. As you can see here, I have a 64-bit Ubuntu virtual machine running inside VirtualBox. This is where we are going to emulate our ARM64 image. As I mentioned, this is a fresh installation. I haven't installed anything inside this virtual machine. So let's begin by doing a quick sudo apt update. The host name here is ARM64. Don't get confused with that. Alright, so the apt update is complete. Now let's quickly install QEMU system. Apt install QEMU system. This is going to install some binaries that we will need later. Alright, the installation appears to be successful. Let's check if we have QEMU system ARM64. Yes, we have. There it is. So our installation is successful. Now the next step is to grab an ARM64 image. I'm going to use this preview image which is available here. It is built in 2018. So when you are doing it, if you find the latest image, you can go ahead and use that latest image and the process should be the same. So I'm going to download this into my virtual machine. So I'm just copying this here and I'm going to create a new directory called ARM64 and let's navigate there. So let's download the image here using wget. So I'm just downloading this. The image is compressed using XZ, so we will have to uncompress it once the download is done. Alright, so the download is complete. Now let's use XZ decompress and let's use the image that we have just downloaded. So I'm just using this compressed file here as our input and let's paste it, and it should produce the img file after decompressing this file. The file is large in size, so it's going to take a bit of time. Looks like it's decompressed, so let's quickly take a look at the contents inside this current directory. As you can see, there is one .img file here. So this is the file that we are going to work with. It will have a root file system and it will have a kernel as well as an initrd image. So we will have to extract the kernel as well as the initrd image to be able to boot this image using QEMU. So we are going to go through that process now. First, let's type sudo fdisk-l and let's use the image as the input. And if you see this, the second partition actually starts at 614400. So let's copy this and let's multiply this using this 512. So I'm just using a calculator. Let's paste it here into 512. This is the value we are going to use to mount this image so that we can extract the Linux kernel as well as the initrd image. Also, we can make changes to this image if we want. So let's type megdir-p/mnt and let's mount at a directory called probably rasp64. Let's call it rasp arm64. Okay, so I'm just creating a directory here. We will have to use sudo. Once this is done, we can mount our image. So I'm just typing sudo mount -o and let's use the offset that we have gotten earlier, which is this 314572800. So I'm just specifying that here. And let's use the image name, which is this. Alright, so let's specify the mount point, which is /mnt/rasp ARM64. Alright, so we have mounted. Now we can extract the kernel as well as the initRD image. So let's type cp and /mnt rasp ARM64, and the kernel name usually starts with VM, so it should be something like VM Linux. If you see, there is only one file here, so let's just copy it into the current directory. There it is. And the next one is to copy the initRD image. Copy that as well. Alright, so in the current directory, if you notice, we have three files. One is the original image, and we have extracted the initRD image and the VM Linux. Now, there is one change that we need to make to this image. So I'm just going to take a look at the contents of /mnt/rasp ARM64/etc/fs tab. If you see this, it shows MMC block 0p2 and MMC block 0p1. We will have to change these to be able to properly emulate using QEMU. So I'm just using sudo vim/mnt/rasp ARM64etc/fs tab. Vim not found, so let's use gedit. So I'm hitting enter, and here it is. So I'm just going to replace this MMC block 0p2 with VDA2, and I'm replacing the second one, which is MMC block 0p1 with VDA1. So let's save the file, and let's quickly double check the changes. There it is. So they are changed. Now the next step is to boot the image using the Linux kernel and the root file system and the initRD image. To do that, we can use QEMU system ARM64 utility, and we will have to pass our arguments to this. I have already created a simple shell script to do this. So let me quickly show my shell script. Here it is. If you notice, we have QEMU system ARM64. The CPU is Cortex A53, and 1024 is the memory that we are specifying. And if you notice, the kernel is VM Linux that we have just copied, and initRD is the image that we have just extracted, and dash drive is where we are actually specifying our image. And if you see this, we have given it a name called drive 0. Similarly, if you attach additional drives, you can name them drive 1, drive 2, drive 3, etc. And then we are appending some arguments, and finally we say no graphic, so the output will be shown on the same terminal. So let's quickly run this and see what happens. I'm typing launch1.sh. The boot process takes a bit of time, and once the booting is complete, we will be able to log in using the default username and password. The default username is root and the password is raspberry. There are some fail warnings, you can ignore them. Alright, so now let's type root, which is the username, and raspberry is the password. I will type the password here on the screen now. So here is the password. You can use that to log in. Now, once this is done, we will come across a few problems. The first problem, you can't reach the internet. There it is. Now let's type ifconfig. It's not found. Let's type ipaddr. And if you see this, the second interface, which is enp0s1, did not get any IP address. So that's a problem. Let's do nano/etc network interfaces.d slash the name of the interface, which is enp0s1 auto enp0s1, and let's also add these contents, and let's save the file. Control X, yes, and hit enter. And let's copy this, and let's also add another interface, because after a reboot I have noticed this image getting a different interface name. Instead of enp0s1, it was getting, after some time it was getting enp0s2. So let's change it. I'm just using enp0s2 this time, and let's add the same content and replace the interface name. So this should fix all the networking issues for now. Alright, let's try powering off, and once that is done, we will log in once again. So I'm just launching the image once again. Okay, so the image is booted. Let's type root and let's log in using the password Raspberry, and this time let's type IP-ADDR, and look at that, we have gotten a NATed IP, so we should be able to reach internet. So with this we should be able to do things like apt update, but there is another problem. The image that we downloaded comes with a very limited hard disk space. I think you can't even do an apt update because it consumes all the space. So our next immediate job is to increase the space of the image. I'm going to power it off, and this time we will have to make some small changes to our launch script. So I'm going to make a quick copy of my launch script so that we can track the changes that we are making to this script. So I'm just calling it launch2.sh. Now what I want to do is I want to make a copy of the original image, and we will increase the size using QEMU-image binary. So let's first copy this, and let's paste the name, and let's call it 10G. If you see, the names are very long, we can actually rename them, but I like to keep them with the original names, because if I access this VM probably after 1 year or 2 years, I will know which image I have used during this process. So I'm just keeping the names as is without changing them. Let's hit enter. This image will also have the size of the original image. We just renamed it with 10G. Now we have to make the changes to this image to increase the disk space. So I'm going to type QEMU-image, and let's type resize, and let's specify this image as the input, and let's add 10 gigs. There it is. As you can see, it says image resized. We have two images in the current directory now. The first one is the original image, and the second one is the new image with more disk space. So let's open up our launch script now. I'm a Vim user, and I think I'll have to install Vim. Otherwise, I'll make too many mistakes by the time we reach the end of the video. Alright, so let's use vim launch2.sh, and let's navigate to this line, and I'm just adding a new line here. If you notice, the first line will still remain the same, and the second line actually has the file resized.image. So let's copy this name here, and let's replace this resized.image with this name. Let's add dash 10G. So that's the secondary disk that we are going to attach. If you notice, I have given drive 0 as the name for the first one, and the second one is given the name drive 1. Alright, so let's save the file and let's run launch2.sh. Let's log in. Now let's type cfdisk/dev/vdb and hit enter. And there is 10 gigs of free space available here. So what I'll do is I'll go here and delete that. And now we are in the free space. Let's hit enter by selecting new. This space becomes /dev/vdb2. Hit enter once again. And let's say primary. Now to write the changes, let's choose write. And if you notice, currently this is /vdb2. Let's hit enter to write the changes. It says, are you sure you want to write the partition table to disk? Say yes. And let's quit. There it is. It says syncing disks. Now we should have more space. There is one more final step that we need to do. Resize to fs/dev/vdb2 and hit enter. Looks like we will have to do this first. So let's copy this and let's paste it here and run this once again. And there you go. Looks like everything is good. Now we should have more space on the disk. So let's just power it off once again. And let's copy our launch script and let's save it as launch3.sh. Alright, now let's copy the name of the image with more size. Now this becomes our primary disk. So I'm just deleting this entry here, the second entry, and I'm going to just instead of pasting it, let me just rename this to -10G. Alright, so if you notice, now we are providing this image as our disk. Right, so that's pretty much it. Now there is one last thing that I want to add to this file, that is adding a port forwarding rule. So let's just add it right after this append line. So here it is. By adding this line, we should be able to log into this system using SSH from our Ubuntu machine. So let's save the file and let's run this launch3.sh. And once the system is up and running, we can open up a new tab and type SSH root at localhost -p2222. That's the port we have forwarded onto port 22 of the QEMU VM. So let's wait for the system to boot. Alright, the boot process is complete. Let's hit enter and let's use Raspberry as the password and log in. And let's quickly check if we have gotten an IP. If you notice, we have ENP0S2 as the interface. Let's check if we have internet connectivity. Yes, we do. So now let's do a quick apt get update. We are pretty much done with the emulation part. We have a working VM that is properly emulated. We have networking issues sorted out, and we have sorted out the disk space problem. So we are pretty much ready. So after doing this apt update, I'm going to quickly run GDB to show that this is a proper ARM64 VM. Okay, so the apt update is done. Let's type GDB, it's not available. Let's type GCC, it's not available. So let's first install GCC apt get install build dash essential. Alright, we are done with installing the build essential, so we should have things like GCC, make, and all this. Now let's check if we have GDB. Still GDB is not installed, so let's use apt get install GDB. After installing GDB, we are going to install Jeff, which is a GDB extension, which is pretty useful for exploit development and reverse engineering. Good part is that GDB is also setting up Python 3.7 for us. So we are going to have Python installed, which is actually required by Jeff as well. So this is going to be useful for us. Alright, so GDB setup is complete. Now let's quickly install curl, which is actually required for Jeff. Jeff can be installed in one line if we have curl installed. Okay, so I'm gonna install curl. Alright, now curl is installed. So as a last step, let's install Jeff for GDB. So I'm just typing this command, which is going to install Jeff for GDB. Alright, so now let's create a simple vulnerable C program and see how it looks like when we open it using GDB. Once again, there is no Vim. I will probably install it later, but for now let's use Nano. And let's use this simple C program and let's save the file, and we have a vulnerable program ready. Now we can use GCC, or we can create a make file and compile this. To keep it simple, let's use GCC and produce the vulnerable binary. Okay, so now we want to use gdb-q, or we can even leave -q, and let's type .vulnerable. If you see, there is an error here. It says Python exception, ASCII codec can't encode character in position 12, ordinal not in range 128. Essentially, we did not get a Jeff shell. We are still inside GDB, and that means Jeff is not working. So this can be fixed by quickly exporting an environment variable, and you can probably later set up an environment variable in your bash profile, but for now I'm just gonna do it on my terminal. And let's run GDB once again, and look at that. So that has fixed the issue. You will need to set this environment variable, and Jeff should work properly. Alright, so now set up a breakpoint at main and run the program, and we can see all the stuff like registers, stack, the disassembly, and everything. So if you notice the registers, these are all of ARM64 registers. So this is how we can set up an ARM64 lab setup for binary exploitation or whatever the research that you want to do.